Okay, so harder trig equations. So hopefully you've seen the first video. If not, please stop right now, go back, watch the first trig equation video because it covers the standard basic types and is crucial to this video. This video is just covering like the different harder variations that can occur. The first one, we're missing a number here, is when the domain is a little different to what we're used to. So this equation here, we're solving this equation, but what makes this one a little bit complicated is we're trying to find all the angles that work between minus 180 degrees right up to positive 180 degrees. The way we do this, well, the first step is going to be really simple, and this is the case for every single trig equation that we deal with in our course. Get the trig function by itself. So let's take that minus 1 across to the other side and then divide by the root 2. Okay, first step is done. We've got our trig function by itself. Cos, we can see here is positive. It's a positive 1 on root 2. So cos is positive in the first and fourth quadrants. So our solutions are going to be in the first and fourth quadrants. And what makes cos 1 on root 2? If you don't have your exact value solutions sorted yet, you're going to have to rely on your calculator, inverse cos 1 on root 2, and you'll end up getting 45 degrees. So our actual solutions will be 45 degrees in the first quadrant and 45 degrees in the fourth quadrants. So what's that going to be? Here we go. X is going to be equal to 45 degrees in the first quadrant is just 45 degrees. And 45 degrees in the fourth quadrant is 360 minus the 45. You end up with 315 degrees. They're your two solutions, and they are actually proper solutions, right? They work. They are solutions that work for this trig equation. The issue is one of those solutions is outside our domain of minus 180 right up to positive 180. It's the 315. So what are we going to do? Well, we're going to rewrite 315 degrees. 315 degrees is exactly the same angle as, in this case, it'll be 315 minus 360, right? And that's minus 45 degrees. Minus 45 degrees is exactly the same as 315 degrees. They're the same angle. So what we're going to do to finish off our solution is make sure our solutions are in the right domain. The first one was good, 45 degrees. The second one we're going to rewrite as minus 45 degrees. Or if you wanted to, you actually could have written this as plus or minus 45 degrees. And that's the first one solved. All right, let's look at the second equation. So do you know what? Actually, some of you probably are wondering, maybe you've missed the video where I explained this. You may be wondering why is 315 the same thing as minus 45 degrees? And I feel like it might just need just a short amount of explaining just for those that maybe are wondering. Let's draw up our quadrants. Let's say we have the angle which is just lying down flat here, right? We know that's going to be, the angle's lying down flat, that's going to be exactly the same as 0 degrees, right? That's 0 degrees. Now, let's say we went up 60 degrees. Here we go. We've got this new angle up here. This is 60 degrees. Well, I could call that 60 degrees. Funnily enough, if I rotate another 360 degrees right around, right? If that arm rotates another 360 degrees, you've now gone 60 degrees plus an extra 360. That's actually 420 degrees. And notice it gets you right back to where you originally were when you had 60 degrees. What I'm saying is 60 degrees and 420 degrees are the same thing. The arm will be in the same spot. You could even rotate right around again if you wanted. If you're at 420 degrees, rotate another 360 degrees. Add 360 onto that. What is that? It's 780 degrees. 780 degrees is exactly the same as 420 degrees, which is exactly the same as 60 degrees. They're all the same angle because they're all in the same spot. And that's what I did over here with the 315. I'm like, that's the angle I want, but it's not in the range, the domain that we're after. So I just rewrote 315 by taking away 360. And so I got the same angle, which is minus 45 degrees. It's the same angle, but it's now inside our domain. So hopefully that made sense. All right, on to the second one. So we're solving this one. The domain's just like the normal, sorry, the range is just a normal sort of domain that we're, the domain, it's a normal domain that we're looking at. So we're just solving this trig equation here. Your first step's always the same. Get the trig function by itself. So let's take that positive 1 across and then divide by the 2. Okay, so we end up with cos 2x is equal to minus a half. So first step was the same. Next step will also be the same. Cos is negative, right? Which two quadrants is cos negative? All stations to central is going to be negative in the second and third. So we've got solutions. We're dealing with the second and third quadrants for this particular question. And what makes cos a half? Again, use calculator if you need to. Inverse cos a half and you get 60 degrees. So we've got solutions of 60 degrees in the second quadrant and 60 degrees in the third quadrant. That means 2x is going to be equal to, notice I've just sort of been ignoring this so far. We haven't really had to do anything with it so far. And that's true. We haven't had to do anything with it yet. I've just been doing everything like normal. 60 degrees in the second quadrant, so it'll be 180 minus 60. And 60 degrees in the third quadrant, that's the 180 plus 60. All right, so we've got these solutions here. And you may be thinking, well, you can see we're trying to solve for x. We haven't got x, we've got 2x, right? So this is simple. We just have to divide by 2. And that is actually correct. That's exactly what we do. 120 will become 60 degrees. The 240 will end up becoming 120 degrees, right? But there's actually, these are both solutions. They both work, they're correct, everything's going fantastic. There's actually more solutions though. Because going from this, completing this final step, when we halved, the angles got significantly smaller. What that means is it allows us to actually fit more of these angles in. I'll show you what I mean. 120 degrees here. That is the same as what? Add the 360 onto it, right? 120 plus 360, you're dealing with 480 degrees. Why have I done that? Because when you do your final step of dividing by 2, right, 480 degrees, you divide it by 2, you end up getting 240 degrees. That is also a solution that works, right? Because if it works for 120, 480 is the same. If it works for 120, it's also going to work for 480. So 240 degrees is also a solution, and it happens to fit inside our domain. And if we look at the second solution we had, which was 240 degrees, well, that is exactly the same as 240 plus 360. That's the same as 600 degrees. And so when you complete your final step of halving, you halve the 600, you end up getting 300, which also fits inside your domain. And you may be thinking, well, couldn't you just keep on adding on 360 onto your solutions? And the answer is yes. So you actually could end up with a whole host of solutions, all of which work. But like I'm saying, we're after all the angles that worked between 0 and 360. So this is where we would stop it here. All right, the next one is kind of the same, but instead of it being times by 2, we're now dividing by 3. I think these ones, if anything, are probably even slightly easier. We do have the added slight irritant of a different domain. But as we've been seeing, as long as you know how to add or subtract by 360, you should be kind of okay with these questions. All right, so let's look at this one. First step, we know what it is. It's the same first step, it always has been. Okay, move that positive root 3 to the other side, and then divide by the 2. Okay, first step is done. All right, sine is negative. Okay, so sine's going to be negative in the third and fourth quadrants. And what makes sine a root 3 on 2? So shift sine or inverse sine root 3 on 2, that gives you 60 degrees. So we're going to be dealing with some solutions in the third and fourth quadrants, the equivalent of 60 degrees. So 60 degrees in the third quadrant is 180 plus 60. 60 degrees in the fourth quadrant is 360 minus 60. You get 300 degrees. Okay, there are like initial solutions. And we're solving for x. So the final step, well, we know how to get rid of it. Divided by 3, we need to times. The problem is when we times these solutions by 3, what's going to happen? The solutions are going to be way too large. Like they're already too large. You times them by 3, they're going to be way too large. So we're going to use our trick of either adding or subtracting by 360 to get them into the domain we want. So in this case here, I'm going to rewrite 240 degrees. I'm going to go down by 360. So that's going to become a minus 120. And I'm going to rewrite that 300 degrees, take away 360 from it. It's going to become a minus 60. Now I can go ahead with my final step. Therefore, x is going to be equal to times by 3. This becomes a minus 360, and this will become a minus 180. And there's no others. I don't know why I did a comment. Then go back up to the domain. We're after all the solutions between minus 180 and positive 180. We have to exclude that first one, unfortunately. Although it does work, we have to exclude it. Minus 180 degrees is, funnily enough, the only angle that works for this equation that is inside this domain. All right, final equation. This one here, as long as you remember the trick, is actually probably the easiest. So if you have a trig equation that has both sine and a cos, we've got this trick. For extension students, you have other issues to deal with because it might not be equal to 0. It might be a 1 there or a minus 1. You have other methods, but for the Mathematics Advanced course, the trick I'm about to show you will always work for these particular trig equations. If you've got a sine and a cos, initially, you know the first step, try and get the trig function by itself. You can't really do that here though because there's two different ones. So we use the trick of dividing the whole thing by cos x. Just the whole equation. Sin x divided by cos x, hopefully you know as tan x. If not, you need to go back and look at the start of the chapter. Cos x divided by cos x will give you a 1, and 0 divided by cos x is 0. What's really great about this is this equation, which had two separate trig functions, has now been converted into an equation that has only one trig function, which we can now get by itself. Tan is positive in the first and third quadrants. What makes tan a 1, right? Inverse tan 1 is 45 degrees. So our solutions will be 45 degrees in the first quadrant, which was 45 degrees, obviously, and 45 degrees in the third quadrant, which is 180 plus 45. And there you have two solutions which work for this trig equation. And I mean that very truthfully, like you can type them in, sine 45 minus cos 45, press equals on your calculator. If it's the correct solution, you should be getting 0. And the same could be said if you replace the 45 with the 225. All right, hopefully this has made sense. Have a go at the questions given and best of luck. All right, bye.